Factoring polynomials. Over the next 3 videos, we'll take a look at different strategies of factoring polynomials. Today's part 1 is dividing polynomials by monomials. So far, we've been working to simplify expressions by collecting like terms. Here's an example. In this expression, we have 2 terms that have an x beside them. So when we collect them, we have negative 2x plus 4x, giving us a final result of positive 2x. We've also looked at distributing. Another word for distributing is multiplying terms. In this example, we have a term on the outside of the brackets that we multiply to both terms on the inside of the bracket to give us our final result. In the following sections, we will be learning how to work backward by decomposition. Decomposition means we're going to be taking some of the terms that we have and breaking them apart or decomposing them into 2 different pieces. We're also going to talk about factoring, and then another way to call factoring is dividing. When we are dividing polynomials, we follow the same rules as we did with distribution, grouping the terms with similar bases and numbers. When we factor or divide a polynomial by a monomial, we have to make sure that we are simplifying each term in the numerator separately. Here's an example. In this example, we have a monomial on top, 1 term, and a monomial in the bottom, also 1 term. When we go to simplify this expression, we want to simplify similar bases, meaning that we're going to simplify numbers with numbers, same base with same base, same base with same base. So each of the variables are simplifying each other. And when we simplify these variables, we are going to use our exponent laws that we learned in Chapter 3. We can reduce 365 and 125 by dividing both top and bottom by 5, giving us 73 over 25. We can reduce x to the power 10 over x to the 3 to x to the 7. And y to the 3 divided by y to the 2 leaves us with just y. So this is our simplified expression. We have divided this polynomial. Sometimes you end up with a fraction, and sometimes you end up with a single number. In our next example, we have a binomial in the numerator, 2 terms, 1 and 2, and a monomial in the denominator. When we have a situation like this, again, remember that each term in the numerator must be treated separately. So I'm going to take that denominator and I'm going to create 2 different fractions with the same denominator, and the numerator are going to be the 2 terms in the top. So what I've done here is I've kept the same numerator and the same denominator, but I have separated them into the 2 terms because there's a binomial in the top. You will also note that the symbol in between my numerator is going to be the symbol in between my 2 fractions. And then I treat this as 2 monomials that I'm going to simplify. So I simplify the numbers and I use the exponent rules to simplify the variables. So for my first fraction, 225 divided by 25 is 9. X to the 4 over x to the 3 is just x. And y squared divided by y squared is 1. So I don't really need to write that. In my next term, 175 over 25 is 7. X to the 5 over x to the 3 is x squared. And y to the 7 over y to the 2 is y to the 5th. And again, I'm using my exponent rules to solve and simplify for this division. One of the things we haven't talked about is what to do with negative exponents. And negative exponents come up when we are using the quotient rule. So let's remember how we showed the quotient rule. When we talked about the quotient rule, we said that when we have the same base, to find the result or to simplify, we take the exponent on the top and then we minus the exponent on the bottom. And the reason this works is because if we wrote out the example in expanded form, so we have here x to the 5th over x to the 2. In expanded form, we see that there are 5 x's multiplying together in the top and 2 x's in the bottom. And because we can cancel like terms or divide them through, x divided by x is 1. X divided by x is 1. 1 times any number is going to give you the same number back. So really, we are just left with 3 x's in the numerator, which is the same as saying x to the power 5 minus 2. And that's how we got our result for the quotient rule. So what happens when we have more x's on the bottom than we do on top? Let's say we have x cubed in the numerator and x to the 7th in the denominator. If I follow my quotient rule, this means that when I simplify, this is 3 minus 7, which is going to give me a final result of x to the power of negative 4. But what does that mean? What does that look like? Let's rewrite our original example in expanded form. So this is what our equation looks like in expanded form. If we simplify, x over x is 1, x over x is 1, x over x is 1, that means the only thing left in our numerator is the number 1 because we've simplified those 3. And what's left in the denominator are 4 x's. So really this simplifies to 1 over x to the power 4. We had 3 x's that canceled out or divided themselves to equal 1. We still have 4 x's in the denominator. So this is actually a new exponent rule that we'll talk more about in grade 10, but it's helpful to know what it means here. If you have more in the exponent of the denominator than you do in the numerator, that means that what you're going to be left with is variables in the denominator with a 1 on top. Let's take a look at an example of what that looks like when we are simplifying polynomials. The first thing I notice is that my numerator is a trinomial. There are 3 terms in the top. Before I start to simplify, I want to separate these into 3 different fractions that have the same denominator because there's only one denominator. So each of my numerators is a term from the top. The symbols in between my fractions are that of the symbols from the top, and whatever is in my denominator is the same for all 3. Now what I'm going to do is I focus on each of the terms individually. I simplify the number part, I simplify the a's, and I simplify the b's to tell me what this fraction is actually going to end up looking like. 196 divided by negative 14 is going to give me negative 14. A to the power 3 over a to the power 5, there are more a's in the bottom than there are on the top. So that means this is going to be a fraction where the a squared is on the bottom, right? 3 minus 5 is negative 2. That means there are 2 extra a's in the bottom than there are on top. For the b's, the top b doesn't have an exponent, but that doesn't mean the exponent is 0, right? There is a b there, so that means the exponent is 1. 1 minus 3 is negative 2. So again here I have more b's in the bottom than I do on top. So this is what my simplified term looks like for the first fraction. I then move on to the second fraction here. Notice that there is a negative on top and a negative on the bottom. So this is going to give me a positive fraction. I then focus on one piece at a time, looking at my numbers, 7/14. That's going to give me a 1/2. Then I look at my A's, 5 A's on top, 5 A's on the bottom. Well, that cancels out or just reduces to 1. Then I look at the B's. I have 6 B's on top, 3 B's on the bottom. 6 minus 3 is positive 3, so I have positive 3 B's, which means this is going to have a B cubed on top. Then I go to my last fraction here. I have a positive sign and a negative sign. This tells me that this fraction is going to be negative. I then focus on my numbers, 21/14. I can reduce that by 7 to give me 3/2. I then focus on my A's, 1 A on top, 5 A's on the bottom. So there's more A's on the bottom, which means I'm going to have 4 A's left over, right? Because one of them cancels out. And then for the B's, I have 2 B's on top, 3 B's on the bottom. So when I minus them, I end up with an extra B on the bottom. So that is what that's going to look like. And I'm going to rewrite this to make it look a little bit neater. And also 1 times B cubed is just B cubed. So I'm going to write my final answer here on the side. Make it look a little bit nicer. This is going to be negative 14 over A squared B squared plus B cubed over 2 minus 3 over 2A to the 4th B. And that is the simplified version of this question. Here's a question that I'd like you to try. Grab a piece of paper and write out this polynomial and divide it by this monomial. Given that there are 3 terms in the numerator, you should have 3 fractions that you separate this into. Remember to focus on the numbers and common bases, and then rewrite your final answer. Pause the video here and try this on your own. When you're ready, hit play for the final answer. I've separated each of the terms. I've simplified the common bases, so my final answer is as follows. Thanks for watching Lesson 5, Part 1 of Dividing Polynomials. Click on the next video for Part 2 of Factoring. Don't forget to subscribe for more videos.